Welcome to live stream number 186. It's always funny when you click a button and nothing happens. You're like, what the heck? I'm a little bit early. Clock is ticking over there. If you're watching the recording, I would definitely not blame you to fast forward just a little bit. See here, we are on the YouTube, but it's always good. We should also, just in a second, if I hit the right mouse, we should also be on Facebook. Thank you so much for joining today's live stream. Like I said, I'm a little early. We still got 2 minutes left. So if you're watching the recording, I don't blame you to fast forward. Today's topic is pattern and mirror with joints. And that's the important thing here. You got a pattern and mirror and you're going to do joints. And then I'm going to show some of my bad habits. What? Me? Bad habits? I'm full of them, folks. And you know it if you follow these live streams on a regular basis. I can see we got Randy here. We got Hanley's here. Really appreciate it. Sander, Jan, Bernie. Really appreciate you guys taking the time. It's good to be back. After last week, I went to Arkansas and Detroit. It was good. It was good. Now I'm back for a few days. We're going to do live stream today. It is Monday, July 16th. If you are watching the recording. Do tomorrow, Wednesday, but then there is the event in Toronto. So no live stream on Thursday the 19th. Don't forget, down in the description area of the video, you can find the link to that event. We're not filled up. There's plenty of space. Plenty of food will be there. Whatever. So if you're interested, go down in the description area and you will find the Fusion 360 for everyone in Toronto, Canada. If you are interested. All right, we are on the last minute here. What else could I tell you? So only 3 live streams this week. I'm sorry. Gotta go to Toronto, but that's how it goes. I will record that event. I will not live stream it. I might do that in the future if they decide we should do more of these. But for this one, I'm going to record it. I'll share some bits and pieces here on the YouTube and on the Facebook for sure. 53 people in the YouTube live stream already. You guys are the best. And it looks like we are on live on the Facebook too. Well, with that, it seems like everything is working. I don't see any reason why not to just stop this clock here. That's why you get my little face here. And let's get going. 3, 2, 1. Wrong button. That's Fusion. Oh. Here we go. Man, I can't take a, I guess I can't take a week off, can I? Okay, now I think I'm good to go. I'm going to try to hit the start button this time. Maybe it works. Hi, everybody. Welcome to live stream number 186. Woo! Rough start here on a Monday. Today's topic is pattern and mirror with joints. And that is important that the with joints in there because 2 weeks ago, live stream number 184, should be a link for this down in the description area, at least in YouTube. I'm not sure if I got it into Facebook. But live stream number 184, we did this part that was an 80-20 rail with a roller on it. We did a joint. We're going to go through that part just in a second. So if you missed it, just at least give you somewhat an opportunity to catch up. Some questions from you guys. My email address is down in the comment area. Came out and that's what we're going to address today. So instead of me talking, let's just get into it here because apparently I can't figure out all these buttons. We are inside of Fusion 360. Woo! And what I did in here was I said new folder and I created a folder called assembly slider. Now if I double click on that one, you'll see that part I used 2 weeks ago. It was called 80-20 roller wheel and motion study. Let me just open it up for a second. So this is the file that I used at that live stream. And let me just minimize the data panel up here so we can see it. And I think today is going to be good for pretty much anybody I think is going to learn something out of today. Now, if you are fairly new, if you feel a little lost, just, watch live stream number 184, link down in the description area. But what we did was we brought this rail and this roller thing here in from the McMaster-Carr catalog. And then we created a joint origin that placed the wheel right on the track. Then when we had done that, we had a sliding joint, but then we put a limit on that joint so it couldn't roll off, because that's a good thing. But then we could also have used a limit on the other end, but what we did instead, if you remember, I don't blame you if you don't, we used these contact sets. That means that when this red bearing comes down, when it literally hits this gray block, then it will stop. That's contact sets. Those are found under the assemble down here. Today you will see I'm going to use the rewind revert position, which just means this roller is going to come back to its original state. So before we get too far into today's topic, I'm just going to roll all the way back to the beginning and take you through. So we brought in the McMaster-Carr. We brought in the rail. Now you see how they kind of like, as they came in here, kind of like in the middle of each other. We grounded thumbtack. We grounded the rail. Did that by right-clicking, hitting ground. Now we're going to unground it. That makes sure that this rail is locked into place. This is going to be one of my, I don't want to call it bad habits, but kind of where the title comes from. We're going to change some of those things today. After we've done that, we created two joint origins. Now they're not going to show up anywhere when you see on the screen unless we're going into each part, each component. You will see we created a joint origin on the roller there. We created a joint origin on the rail there, and then we mated those two together. Now, if you're wondering about those joint origins, again, live stream number 184, that is 2 ones back, so go a couple weeks back here. And when we created that, we also created a sliding thing where we then, to limit it, we went into the joints folder, found the slider, we right-clicked on it, we select edit joint limits. We talked about the importance about maximum and minimum. But generally what we did was we said stop here, but then we just put a fictive number that let it roll off the rail down here. And then I took the opportunity to show you that if we created a component, a couple of sketches, and I kind of created this little block down here, stopping block. Now that one at this point was floating around, right? So what we did was we thumbtagged that one into place by right-clicking on it and say ground. So now that is in place. And then I did slide down with a revert here. And then we created this contact set that when the red portion slides down and hits the gray one, it stops. So a little bit different than a joint limit where we actually have these two joint origins kind of like limit their travel. With the contact set, we're actually kind of banging into this gray piece, and that kind of like resolves that. Now, I talked on in that live stream in the end that using thumbtacks maybe is a little bit of a cheat. You could instead, and then I deleted it, or removed it, you could instead use rigid group, also found under assemble, where I grouped these two together as a rigid group. It means they couldn't move. So that is this part you're seeing on your screen here from the live stream 184. So maybe you need to rewatch it, maybe you don't. Maybe you're all set now. I don't know. All right, so we're 6 minutes in here. Hope that was a good review. Just trying to catch you up. If not, again, watch 184. Let's move on. So the question that came out of this live stream, but was a very good one, couple of different ones, was that, okay, this is all cool. We now got this thing moving along here. Revert back to center. What if I wanted to pattern this? So we could go say, all right, create pattern. Let's do a rectangular pattern. Click on that. And instead of selecting faces, I'm going to select components. And I'm going to select 1, 2, 3 components. Then I'm going to say in a direction. I'm going to select this edge here. Let's just drag a couple of patterns out and hit OK. Okay, that looks pretty promising, right? Until you start moving around here and you realize that this is maybe not what you wanted. You wanted this. Okay, let me just go delete that rectangular pattern, back to normal. The other question was, I have this. Now I want to mirror it. So we click mirror. Let's do a mirror 200 millimeters from this face. Do kind of the same thing. Go down here and say mirror. Instead of faces, let's say component. Let's select those 3 components. Boom. Let's mirror it over this plane. It all looks good, but kind of same issue. Everything's floating around. I want this. Do I really have to do all the work? This is not really what I was expecting, Lars. Come on. Well, what are we going to do? Well, we have a couple of different things we are going to talk about. And again, I really, my goal is that today is going to be shining some light on the ways that that Fusion handles some of the stuff, and hopefully that would be somewhat useful. So this is where it kind of like comes into to Lars's bad habits, and I do have them. That's absolutely true. What happens is the same thing that I think happens to most of you guys, is you're modeling things up kind of like in the order of what you think you're gonna need it for. So when I model this thing up, I never really thought about somebody gonna say, well, we gotta pattern it. And this happens quite a bit to me too. So don't think you're out of the, where you model something up and then you're thinking, all right, now I wanna do this. And then you're like, oh, well, wait a minute. So we're gonna talk a little bit about best practices. We're gonna talk a little bit about doing things possibly a little bit different. See what happens in Fusion, as I model this up here. For example, let's just use the pattern example right now. If I go in and say a rectangular pattern, we saw that before. I select the components and I do a direction. But what happens here is that I'm just patterning the components. I'm not patterning the joints or the contact sets or anything like that. So that's the first thing to kind of like just understanding what happens. That when you say in here pattern components, well, that's all it does. It just patterns the components. Now there is a way around this, and I'm gonna mix in like what I would call my bad habits, or kind of like as I'm going along. But check this out. If I went in and I created a new component up here, see right now this is an assembly. And we know this is assembly because it has the assemble icon up here, and then we have 3 components within that. That becomes an assembly, and that's where the only place we can make joints really is inside an assembly. If I go up here and create another component, so there's nothing inside this one right now. Let's just right click here so we can name it. Let's call this a sub-assembly. Now again, there's nothing in here. And by the way, now while we are naming things, let's go up to this end plate and rename that. And also the rail, because this is the one that's going to kind of matter the most as we're going along here. We could call this a wheel. Now we've done all the stuff we needed. Okay. See, right now in this sub-assembly, check this out. If I go up and I take the wheel and the rail, hold down control, and the end plate, and I drag them into this sub-assembly folder, then this does become a sub-assembly within the assembly. See how the icon changes? Let me just do a Control Z, undo. See how here it just is a normal, it's just an assembly. It's not a sub-assembly. It was just something we named it. But as soon as we drag these 3 components into it, it now knows it's a sub-assembly. Now notice an interesting thing here when I hit the little arrow next to it. The joint folder went with it. Okay, that's interesting. So when components with joints with them gets dragged in to another component, so it becomes a subassembly, it brings the joint folders with it. So remember that. So that's a good thing when we're getting into patterning it. Okay. Now, one thing you will notice though, let me just do a control undo again. Back to here. We had the rail set with a thumbtack on it that had been grounded, right, by right-clicking and say ground. And that's really just putting a nail in space so this thing can't move. And also note that inside the joint, besides our slider, we had that rigid group where we had kind of grouped these together. Notice what happens when I drag these three components into that subassembly, or makes it a subassembly. Notice the thumbtack is gone and the rigid group is gone. What really means that right now, when I dragged it into a subassembly, everything is loose. Okay, so this comes a little bit to bad habits from Lars, if you want to call it something. So let me just delete this subassembly again and go all the way back to when I started this whole thing. Now I'm back to where I started, like when I brought the file in. So a couple of things here that I call my bad habits, or things you should be aware of when you're working in this environment. First off, be aware of the contact sets. Remember, dragging this thing up and slamming into something. Contact sets will always work in the top of an assembly. They cannot go down to sub-assemblies like we did before. So that's important to know. And then also, as contact sets are cool, because it kind of like sees that stopping block and slapping into it, they are very heavy on kind of like computer power. So as your assemblies getting bigger, contact sets could drain it down. So I actually, for my first bad habit, I'm actually only going to use contact sets whenever I really need it and I couldn't use a joint. So I'm actually going to right click here and I'm going to disable the contact set. Now you see it's gone. Now again, if you didn't watch live stream 184, contact sets is sitting under the assemble dropdown. This of course means that now this thing can drag back off here. So what I'm going to do is I'm just going to do a quick measure and I'm going to select a point over here on the edge of the rail and a point over here. And if I check XYZ delta, that will give me the distance, what is 609.6. I can't remember anything, so I'm just going to click on this. Now it's copied to my clipboard. Let me go into the joint, right click, edit joint limits. And on the minus here, I'm instead going to say minus and paste that number in. And this is when we talked about Friday, that this can be a little bit tricky. Oh, sorry, because I'm doing this wrong. This always have to be the minimum. I messed it up. Minus 10. Minus. There we go. That should do it. Okay. I had two minuses in front of it. There we go. And this should be minus 10. I'm keeping on getting the second minus, and that's what screws me up. There we go. This is the order, with this being minus 10. Dang it. Okay. Now I got this messed up. Hang on. Added. I was in such a good rhythm. 609.6. There we go. But then I just noticed that this thing is actually halfway through, so it should probably be 589. There we go. I don't know why this does not want to stay at 10. now. Okay, now we got the travel. So instead of doing the enable contact sets, we changed it with the limits instead, and then we solved that problem. Get rid of those if you can. And I'm going to do another live stream on heavy duty assemblies later on, but that's a good habit to only use contact sets whenever you really need it. And in my last live stream, I was just kind of like trying to show you could do it. All right, so with that done, we have eliminated that issue when we go into to pattern this. The next thing is this rigid group that I used. You saw that didn't come in either. So I'm actually going to delete that here. But of course, that means that now this floats around. And that brings me to another, I would say, best practice. Is that rigid group is cool, but there is one that is better. And that is called as-built joint. If you select this one, as-built joint, and you select those two components, you can select that they are rigid, and they will kind of like do the same thing as the rigid group did. Let's go delete that out of there. Okay, so again, we still got the movement here, but instead of being rigid group, this has now been as-built joint, and that actually goes for the rail too. Instead of using the right click and ground, you could, let me unground this, you could here also use as-built joint between this one and then the top up here. Okay? All right, so now we have this thing can move, this thing, I just deleted that before, didn't I? As-built joint. Okay. Now in here, in the joints folder, we have the slider that we have now solved, can travel back and forth. We have the rigid group that is going from here up to the top, and then we got the rigid group between these two. So now, when we have done that, my bad habits, whatever you want to call it, now if we go in and say, all right, let's now pattern this. Oh no, first we got to create a subassembly. Right click, new component. Again, this is just a component. I rename it subassembly, like this. Let me drag our three things in here, like this. Now that's a subassembly. Now if you're looking in the joints, you will see two of them went with it. And you're saying, well, wait a minute, why is only two of them going with it and not three, as I just showed you that was in there before? The reason was that the rail here was, the rail that was in here was up to number 2. It have now lost its rigidity, is now to number 1. But what happens now, I hope that this is not confusing. If I go into rectangular patterns, I go to components. Now this time I'm just going to select that sub-assembly. I'm going to extrude it, I'm going to pattern it 3 ways, like this. So that came up there, right? Now check this out. This will still move like this, but all I have to do now is to go into the second subassembly, say as-built joint. I'm going to select that rail again up to the top, and now you will see that that one now have the joint with it. And then I want to do the same thing to subassembly 3. So if you are patterning with this, go in and use the as-built joint and do that up to the top. So now you have patterned this with the 3 kind of there. So I hope that was not too confusing. Maybe it was. I always doubt this. But you let me know in the comments area, in the comments beneath. Now, before I finish, let me just save this out. So I'm going to go ahead and say save as. And let's save this as pattern, I don't know, pattern. That's good enough. Save it in the same folder there. Now, if I go back, so now we have the unlimited and the pattern there. Now, if we go back to the original one I did before, you might say, all right, so give me the mirror one. Well, in the mirror, the same thing happens, except a mirror command will not bring the joint over like the linear pattern did. So you have two different options if you were going to do this. Now, I would still do, what I actually would do instead, if I was going to mirror this over, I think I would save this out as its own file. So what I would do was I would probably go back to my bad habits and get rid of the contact set, right? And then I would go into the joint slider, edit the joint, and I would change this here to minus, what did we figure out? 590.6. So now this is doing, the slider is going like this. I would get rid of the rigid group because we've kind of determined that that works for whatever. It's not that this is bad practice. It works for whatever you wanted to do. But if you're getting to this point, then you might want to get rid of it. And then instead of using the rigid group, then it might be better to use as built joint. So select these two. And then we could decide that we just don't want to use ground. We could leave ground, but could just say that we don't want to use it and continue using as-built joints. The only thing I don't like about as-built joints is that you don't see it. Now you don't see which one is grounded versus if you right-click and you ground it, you get the thumbtack here. That's maybe my only one. But now we're kind of like back to where we were before. So like I said, there's no really reason here to turn this into a sub-assembly because joints don't come with it. So we could just save this as rail for mirror, like this. Okay. And then what I would do, now where we have that one out there, is I would start a new document. I would save it as assembly. So this is just an empty document right now. Then I would insert this one. Right click, insert current to the sign. Comes in here, right? We can hit OK here. And again, you can, we talked about this before, break or unbreak the link, whatever you want. Now this one is, again, floating around. So the same principles we did before. As-built joint for the rail there to this. Okay, so now this is working. And then instead, if you want to get a mirror, you have a couple of different options. You could go in here, insert another one. Now it's going to come in on top, but remember you get this free move when you're inserting the second one, and this would not be mirror, this would be rotate. But if these two wheels are symmetrical, you could just drag it around like that, right? Because you get this free move. And then we could do the same thing. Right click, I like to break the link. And then go in and do the same thing as before. And say as-built joint. Here to here. And now I have that there. And I have that there. If you do want an exact mirror, because of these are maybe not the same, then the trick would be to actually, you have to reinsert those joint origins. So what I would do at that point, of course, I would offset this to the right distance. So let's go and find the wheel here. Let me just delete that for a second. So now that is deleted. We could go in here and say, create a plane, a mid-plane between this face and this face. Then you could go in here and say, I want to mirror this component over this line. So now it is a mirror of the original. However, this thing is now floating around in space, and now you would have to go in and do those joint origin again, as we did in the first live stream. We did in 184, and you could place it back in there. Now you would have a mirror of it. How was this? Was this rough for Monday? This might have been very, very rough for Monday. Feel like I jumped around a little bit. I hope this was useful. That was what I was planning on sharing today. It is hot in my office, friends, if you can see me sweating here. But I hope this was useful. You let me know. Thumbs up if you like this. Thumbs down if you don't. Leave a comment. I need your feedback. I beg you. Even if it's bad, I'm okay with that. I'm not going to cry. Yeah. I hope this kind of like took that thing to a little bit of a different level. I hope you got to see some tips and tricks, like creating that sub-assembly out of it, brings the joints in, some of the good things and bad things about rigid group, and using as-built joints. That, friends, was all I was planning on showing today. There will be another live stream tomorrow, same time, 3 o'clock. Don't forget, down in the description area, you'll find my email address. You will find, for Thursday's event in Toronto, Canada, you will find a download for the free CNC Handbook. That's it. I'm going to end it right there. I hope you have an awesome, awesome day. And if you're watching the recording, thank you so much. If you are in the chat, I'm going to come in and say hi to you. Take care, everybody, and have an awesome, awesome day. Take care.